Welcome to another Ginger Mathematician video. So this is a re-upload of my November 2016 paper 2. I've added a few little bits and pieces, including some music in the background. Please let me know if you like this new re-upload. Okay, enjoy. Okay, welcome to another Ginger Mathematician video. This is the kind of video I haven't done for quite a while. So we're going to do another walkthrough. We're going to take another paper 2. This time it's the November 2016 paper. I'm going to take paper 2.2. This is the iGCSE 0607 International Mathematics. The first thing you should do is check if you do the 067 course or do the 0580 course. So you do the 0580 course. Mathsaurus does some excellent videos on that, so please check him out. But if you do the 0607 International Mathematics course, then I am your man for this particular course. So let's get started straight away. So we're going to do this particular paper here. So notice it's a 2.2 paper. So there are 3 different papers, 2.1, 2.2, 2.3. Comes from November 2016, so one of the recent papers, 45 minutes long. Okay, please be familiar with this, and calculators will not be used for this. So I will split this into 2 videos. I'll do questions 1 to 7 in this video, and then I'll do 8 to 12 in the subsequent video. Right, if you like this video, then please like, please subscribe. Please let your friends know that there are videos like this out there to help you with your mathematics. And eventually I will go through every single paper, but not quite yet. I will try and do my best. Right, let's get started. So, our first question is to write down a prime number. So remember, a prime number is any number that's got 2 factors, 1 and itself. So we need to look for a number that's not divisible by 2 or 3 or anything else. Well, we can cross out all the even numbers because 2 goes into those. 5 goes into 25, so we can cross out that. And 3 goes into 27. Okay, I know that because if I add the digits, 2 plus 7 is equal to 9, and I know 3 goes into that. So our prime number must be 29. They always like a couple of warm-up questions on this paper. Our next one is the $84 is divided in the ratio 3 to 4. And we want to find the value of the largest share. This is a standard dividing by a ratio question. We do this in 3 easy steps. So first of all, we add together 3 and 4, which is equal to 7. Our second step is that we take this number and then divide 84 by that number. So 84 divided by 7, which you can do mentally and work out is 12. If you find that a bit tricky, the 12 times table, you can always use everyone's favourite bus stop method. How many 7s go into 8? Well, 1, carried a 1. How many 7s go into 14? That'll be 2. And then finally, we need to read the question carefully. We want to find the value of the largest share, so the part represented by the 4. So we take the number we just did, we do 12 times 4, and that's going to be equal to 48. So that's going to be our answer for 2 marks. You do need to show working and be efficient with showing working. So if I show you the mark scheme, you've just got to show for one method mark 84 divided by 7 in some shape or form, which I have shown in this part here. Okay, as you can see, these first couple of questions are usually more like warm-up questions, and they get a bit meatier as we go along. So let's continue. So question 3, in a sale, the price of all furniture is reduced, so it goes downwards, by 30%. Before the sale, the price of the chair was $40, and now we want to work out the price of the chair in the sale. So we want to work out, first of all, 30% of 40. So we can see what reduction is taken from the $40. Well, to work out 30% of $40, we always use our fundamentals with percentages. So 10% of 40, well, we just divide it by 10, and that gives us 4. So what do we do to 10 to get to 30? Well, we times by 3. So that's going to give us 12. But remember, $12 is not our final answer. It's the money we're going to take off from the price of the chair. So then we need to do 40 minus 12, and that's equal to 28. So the price of the chair is now $28. A complete bargain. Excellent. The next question is a bit trickier. It works kind of the other way around. So in the sale, the price of the table is $140, and we want to work backwards to work out the price of the table before the sale. So if the initial price was 100% and we take away 30%, that means that the price we have currently is worth 70%. Yeah, this comes from 100%, the original price, then minus that 30%. So 70% is equal to 140, and what we want to work out is that original price, which is 100%. So how can we go from 70 to 100 by timesing and multiplying, doing the same thing on both sides? Well, probably the most straightforward way is to divide by 7 on both sides. Again, we want to try and aim to get things out of 10 or out of 1. So if we do that, 70 divided by 7 is equal to 10, so 10%. And 140 divided by 7, well, how many 7s go into 14? That's going to be twice, so that gives us 20. And then finally, what do we do to 10 to get to 100? Well, we multiply by 10. We do the same on both sides, and 20 times 10 is equal to 200, which gives us our answer for 3 marks. Now, if you're in the exam and you have time, you can actually check this. So if I worked out 30% of 200, you would work this out to be 60, and then 200 minus 60 is equal to 140, which is the new sale price of our table. So if you have a chance in the exam, check by finding 30% of the 200, take that away from 200, and you should get back to the original answer here. So, quick look at the mark scheme. Notice any calculation that gives you 40 times 0.7 or equivalent. The way we did this is work out 30% and take it away, which is fine. And then we did this method here. So M1 for 140 is equal to 70%. And then dividing by 0.7, well, that's the same as dividing by 7 here and then timesing by 10. It's the same operation. You'll notice on the mark scheme, it says OE. This is important to realise if you do this exam, and that stands for or equivalent, i.e. the calculation I did in 2 steps rather than 1 is equivalent to this one here, is equivalent to dividing by 0.7. It's the same calculation. So when you ever see OE, you can use a different method, but as long as you're doing the same mathematical operation. Okay, let's keep moving on through. So we're on to some standard form. We need to work out the following, giving each answer in standard form. Now, there are 2 main ways to do a kind of question like this. The longer method is to convert both into real numbers, like 0.064 for example, and then take them away and then convert them back into standard form. But notice this is a 2-mark question, so you've got about 2 minutes to actually do this question, so you need to be quite efficient with your time. Actually, strictly speaking, it should be a little bit more than 2 minutes. So the way we do this is convert both these numbers to the same base, so they have the same power of 10. Now, the way we can do this is we can times the right-hand side by 10 and divide the left-hand side by 10. Notice we're not changing what the number is because we're timesing by 10 on the power and dividing by 10 by the number. And if you times by 10 and divide by 10, it doesn't change what it is. And you'll see why we do this. So 10 to the power of minus 3 times 10 to the power of 1, we add the indices together. So minus 3 plus 1 is 10 to the power of minus 2. And then 1.6 divided by 10, well, that's going to be equal to 0.16. And you're probably wondering why we've actually gone to the effort of actually doing this. This kind of seems like extra work for no reason. But the great thing about this method is once we've done this kind of strange calculation, because they have the same base, we can just minus them as normal. So we get to our answer of, well, 6.4 minus 0.16, that's going to be equal to 6.24. Remember, if you're minusing, I'll write this out in full. Yeah, make sure the decimals are in the right place. So we can quickly go through. That's equal to 4, that's equal to 2, that's equal to 6. So make sure you can subtract decimals correctly. And then the base stays the same when we're minusing. So we automatically then just get to the correct answer. And this is what the iGCSE want you to do because it's only a 2-mark question. They don't want you to actually convert it into an ordinary number and then work it out and convert it back. That takes far too long. So please do watch this part of the video again if you're not sure what to do. And if you found this difficult, I did a video on what I call iGCSE Mathematics Minis, where I go through index laws and I go through questions like this. So do check that out. I'll put something in the video so you can check that out and see that either at the end of the video or at this point. Dividing is a bit easier, so dividing works in a more straightforward way, where the way we do this is we do 6.4 divided by 4. So we divide the numbers, work out an answer, which we'll do, and then we divide the powers. So 10 to the power of minus 2 divided by 10 to the power of minus 3. Oh, I just realised I gave the answer away by not writing down the right calculation. That's kind of funny, because I knew the answer was 4, but I wrote down, 4 instead of 1.6. The way we do this is how many 1.6s fit into 6.4. Well, if we count, we've got 1.6, keep adding on 1.6 each time. Hopefully you'll agree that it goes in exactly 4 times. And remember, this is a non-calculator paper, so they'll make the calculations easier. For this one here, this is a bit trickier. So 10 to the power of minus 2 divided by 10 to the power of minus 3. Remember, we minus the indices, but we have to be careful because we have a minus here and we have a minus here. So 2 minuses make a plus. So you get 10 to the power of minus 2 plus 3, and that's equal to 10 to the power of 1, or just 10 itself. So combining these answers together, we get 4 times 10 to the power of 1. And we are finished. We are done. Okay, let's just check the mark scheme. See how we go. So you can see the 1 is not necessary, you don't need that there. You get 1 base mark just for putting 4 down. So realizing that 6.4 divided by 1.6 is 4. So this shows you it's very important to write down the working. Make sure you do that. And then the next question, you can see some methods that do it this way, or if you show this calculation, which is the way that we did it. So you have this 0.16 times 10 to the power of minus 2. Okay, so this is a quite standard form question. Doesn't come up every year. They vary the index laws questions somewhat, but this comes up, I'd say, on paper 2 50% of the time. So it's definitely something you can't be surprised about if it appears. Right, carrying on, got some relative frequency. So one day there were 720 students at a school. The table shows the type of transport they use. So we have this table where we do not know what x is and we have to find it out. Well, we know the total students is 720. So if we add all these up together, they need to make 720. So if we add together 280, 240, and 170, we get 7. 8 plus 4 plus 1 is equal to 13. Carried a 1. 2 plus 2 plus 1 plus 1 is equal to 6. And then we need to do 720. You can do this mentally, of course. Minus 637. And this is standard subtraction. Equal to 3. That will become equal to 11. And then we get our answer of 83. And of course you can always check this to make sure that's the correct answer. So 83 plus 117, that's going to give me my 200, and then 440, 520, 720. So you should always take the chance to actually check the number worked out, even for that 1 mark. Okay, and now we need to find the relative frequency, and this is kind of a strange kind of word for essentially the probability, yeah, or the experimental probability. So you ever see this word, it means the probability. Because the trickiest part of this question is knowing what to do, and we need to simplify our fraction. So it kind of gives you a clue it's going to be a fraction. So we look at how many people travel by car, which is 240. We see how many travelled in total, which is 720, and now we need to simplify this fraction for the second mark. Well, we can cancel the zeros, top and bottom, so we get 24 out of 72. Now if you know your 24 times table, that's fantastic. Many people don't, so we can always divide through by 8. So how many 8s go into 24? That's 3. How many 8s go into 72? That's 9. And I think at this point we can see we'll get to our answer of 1/3, or a third. Okay, look at the mark scheme for anything to add. Notice you get the method mark just for writing down the original fraction. Again, this is why you write your working, you write these key bits of information as you go through. Particularly important for paper 6, but also for the paper 2 as well. Make sure you're picking up those method marks where you can. Okay, let's continue. So this time we've got a probability question. I like this one. So a bag contains 10 discs, 5 are red, 4 are blue, and 1 is green. A disc is chosen at random, and this is the key phrase of the question, not replaced. So once we've chosen a blue disc, then it's been removed. So keep that in mind. So find the probability that both discs are green. Well, we've only got 1 green disc, so there's no chance of there being 2 green discs to choose. So this one is just going to be 0. I'll go through that again. The probability that the 2 discs you choose are green, well, because we only have 1 green disc, we can't choose 2 green discs. So the probability must be 0. 1 mark question for a reason. Again, we don't need any extra working than that. And this kind of leads into the next question, which 6b, which is both discs are the same colour. So we know they can't both be green, so the only probabilities they can be is that they're both red and red, or, and that's why I'm putting a plus here, they can be blue and blue. So when we draw our tree diagram, which I'm sure you've been taught in lesson, first of all, green we can dismiss. We're not going to do anything with green. So at the first pick we get red and blue. Okay, so we can ignore green. And then, so we're just going to focus on red and blue. Then you've got the choice of choosing red or blue. So notice I haven't drawn the entire tree diagram here. I've only drawn in what I need to work out, and the probabilities I need to work out are red, red, both red, or blue, blue. Both are blue. So let's work these out. So the red probability at the start is 5 out of 10. So there are 5 discs red out of 10. Now imagine we've chosen one red and we've removed it. There are only 4 red discs left. And because we've removed a red disc, there are only 9 left in the bag. So this becomes 4 over 9. Likewise for blue, we had 4 blue discs out of 10, so we're going back to beginning. So the probability of choosing blue was 4 out of 10. And then the probability of choosing another blue disc after this, well, we have 1 less than 4 now, which is 3. And then we've got 1 less than 10 because we only got 9 discs left in the bag. Notice all the fractions here will be out of 9 because we've already chosen a disc, whereas all the probabilities here are going to be out of 10. And now we work out the 2 probabilities individually. So we always multiply along the branches. So we're going to work out 5/10 times 4/9. That's equivalent to working out the 2 reds. So that's equal to 20 out of 90. Remember, multiplying fractions, you just times the top and times the bottom. This one will do a similar calculation. So we're going to multiply 4/10 along the branches times 3/9. That gives us 12 out of 90. And then finally we're going to add those together, and that gives us 32 out of 90, which I don't think, strictly speaking, you need to simplify, but if we simplify, divide it by 2, we get 16 out of 45, and we have a quick look, and we can't simplify it any further, so our answer will be 16 out of 45 for our 3 marks. And do they simplify? They do not simplify. There we are. Interesting. So 0 gives you the 1 mark, 1 method mark for doing one of these calculations, 2 marks for doing both calculations and adding them together, and then 32 out of 90 or equivalent, or 16 out of 45 is the same as 32 out of 90. Kind of noticed on these 0607 papers, the probability question specifically, if you do not simplify at the end, it's not a problem. Okay, and the last question in this video is we've got some expanding brackets and simplifying. They like these a lot on paper 2 on the 0607 course, so make sure you can do these multiplying out single and double brackets. This one we need to be careful of that minus in the middle. I already know that, so keep that in mind. So we're going to multiply out these single brackets using what I like to call the hook. So let's do it one at a time. 3x times 4 is equal to 12x. 3x times minus 5x is minus 15x squared. Minus 5x times 3x is minus 15x squared. And finally, minus 5x times plus 2 is equal to minus 10x. And now we simplify, so we collect up like terms. So the way I like to do this, let's use a little bit of colour. Colour is always good. We've got a plus 10x here and a minus 10x that we can collect, and then we collect the middle terms together. Remember, you can only collect up like terms. X squared collect with x squareds, x's collect with x's. So 12x minus 10x is equal to 2x. And minus 15x squared minus 15x squared, this is where we have to be careful, is minus 30x squared for our 2 marks. So I'll just show you in terms of working. Okay, you could also factorize it as well, this is true. And notice you get the base mark for doing this calculation or this calculation. So that's where you would pick up 1 method mark if you did not simplify this part correctly. And the next part, we're going to use FOIL, or the eyebrows. This is done in many different ways. We just have to make sure everything is multiplied by everything. So some of you may have done this by FOIL, so I'll talk this through as we go. So FOIL is the first term, which is 4x times 3x. So that's going to give me 12x squared. Then we do the outside terms. So 4x times 2y is equal to 8xy. Then we do the inside terms. So minus y times 3x is equal to minus 3xy. And then the last terms, minus y times plus 2y is minus 2y squared. Not forgetting the squared part. We can now put the middle terms together. So notice they're both in terms of xy. So we can collect those together. So 8xy minus 3xy is equal to 5xy. However, notice we can't collect together x squareds and 2y and y squareds. So this is now our final answer. So 12x squared plus 5xy minus 2y squared. And we're done. There's no factorising there, although that's not necessary. As you can see, they can't factorise this anyway. You get B2 for this stage here, so you get 2 marks out of 3, even if you did the collecting in the middle incorrectly. And you get 1 method mark with 1 wrong term. So say you did one of these wrong, you still get 1 method mark. So it shows you how important it is to make sure you set out your working, make sure you can pick up those method marks when they come along. We are now on to question 8, which is finding the value of 64 to the power of a third. So remember, whenever you have a fraction as an index, then it's some kind of root, and because we have a 3 here, it's going to be the cube root of 64. And remember, cube root, what that means is something times something times something is equal to 64. What would that something be? Remember, it's a non-calculator paper. Well, that's going to have to be 4, because 4 times 4 is 16, 16 times 4 is 64. Good. And next question, highest common factor, but in a slightly different way. So we need to find what they have in common. So the first thing we do is start with number. So what do 8 and 12 have in common? Well, they have a 4 in common. 4 goes into both. So I'm going to cross that out. I've done that. Okay, how many x's go into both? Well, I've got x cubed here and x to the power of 4 here. So I've got x, that's 3 x's, and then 4 x's here. So they have 3 in common. So that's going to be x cubed. We do the same thing for y. So how many y's do they have in common? Well, that's going to be a single y. So we can pop that in for our 2 marks. Again, 2 marks, we need to show some kind of working. So you can see that any 2 parts are correct. So say you got the x cubed right, but not the 4, but you got the y right, that's absolutely fine for 1 mark. Okay, one of my people that commented said, keep the videos as quick as you would do it in the normal iGCSE. So I'm doing my best. So this one, very common. We need to rationalize our denominator. That means make the denominator a whole number. So in this case, the standard process is to multiply top and bottom by that surd, that root. The reason we do this is so we can get a whole number on the bottom. And remember, if you multiply root 3 by root over root 3, you're just like multiplying by 1. It doesn't change what it is. Multiplying fractions, we multiply the top together. So 6 times root 3, that's going to be 6 root 3. And then root 3 times root 3 is equal to 3. But we're not finished. We still need to cancel the numbers here. So how many 3's go into 3? Well, that's 1. How many 3's go into 6? That's 2. So our final answer is 2 root 3. Biggest mistake that's made is not doing that simplifying and making sure you get that second mark. That's very, very important. Now part B is slightly different because we have this plus in the middle. So we need to multiply by what's called its conjugate. That's like the negative version of it, if you will. So what we'll do here is we're going to multiply by, I'm going to put this in brackets to remind us to use FOIL. We're going to multiply top and bottom by 2 minus root 3. The reason for doing this, once we've done our FOIL method, we'll find we get a whole number on the bottom. First of all, let's multiply out the single bracket. So root 3 times 2, that's equal to 2 root 3. And then root 3 times minus root 3. Well, let's go through this. Root 3 times root 3 is 3. And the plus and the minus makes a minus. So we get minus 3. And now we use FOIL on the bottom. So we do first, 2 times 2 is 4. Then we do the outside. 2 times minus root 3 is minus 2 root 3. Then we do the inside. 2 times plus root 3 is plus 2 root 3. And then plus root 3 times minus root 3. Well, that's going to give us a minus 3. The great thing about this process is that the middle terms, these things cancel, which makes our life a lot easier. Get my red pen out, I like my red pen. And then we get 2 root 3 minus 3 at the top. And 4 minus 3 is equal to 1. So we're just left with a numerator. So we write that in. 2 root 3 minus 3. And we're done. So here are the answers here. 1 mark for realizing to do the root 3 over root 3. You can pick up method marks just by showing your thinking. Very, very important. Likewise, as long as you show you're multiplying by 2 minus root 3, you pick up a method mark, which is fantastic. Let's keep going. Let's keep moving on through. This is a lovely 5-mark question. Standard. I've seen it appear in 2019, 2020 more often. So something to remember. So we have 2 points. We want to find the equation of the perpendicular bisector. If you do applications IB, you'll see this again. So it's a really important skill to master. We do this in 4 simple steps. So step 1 is to find the midpoint between the 2 points. Okay, we'll use that later on, but we need to establish our midpoint. So imagine we join up these 2 points. I'm going to try and do this best I can. That was reasonably straight. There's my midpoint. And the way I tend to teach this is like look at our coordinates that we have and think what's halfway between 3 and 6. Well, halfway between 3 and 9 is 6. Okay, you can use a number line, or if you like a formula here, the formula is to add them together and divide by 2. That will give you 6. And likewise, what's halfway between 8 and 0? That's going to be 4. And if we look at our diagram, it looks like 6, 4 as well. That would be a sensible answer. If you want a formula, I know people love formulas, you just do a plus 0 divided by 2 to give you 4. Okay, midpoint's the first thing we found. Number 2 is the gradient. So we're going to need to find the gradient of the red line I've drawn. Now, there's a couple of ways it can be taught this. Most people here rise over run. So the change in y over change in x. Or some people like the formula, so you can do y2 minus y1 over x2 minus x1. I tend to do this quite visually, so let's get out my green pen. Give myself a target of half an hour for these questions. So imagine we make up a triangle. So looking at this, the difference in height, well, 0 and 8, that's going to be 8. And then the difference in length between 3 and 9, that's going to be 6. Okay, and now we need to work out exactly what the gradient is here. So we can use our formula, or we can use what I've done on the board as well. So if we do y2 minus y1, we can do then 8 minus 0 over 3 minus 9. And so we get 8 divided by minus 6. You can do it the other way around as well. That doesn't matter. And then we get minus 8 over 6, which if we simplify is the same as minus 4/3. Notice you could use this method as well to get to this point. Okay, step number 3, we've worked out the gradient of the red line. What we want is the gradient of the perpendicular bisector. So the grad of the perpendicular bisector, PB. Okay, so what we do to get that, and let me draw in what this perpendicular bisector is going to look like. It's the line that goes in this direction, and it makes a right angle with this. And the way we can work this out is what's called the negative reciprocal. So we flip that fraction and change it from a minus to a positive. So our gradient is going to be 3/4. So we know that the perpendicular bisector can be written in this form: y equals 3 over 4x plus c. And now we need to work out what this c is, and this is where our midpoint from step 1 comes in. So we're going to insert that in. So, yeah, my accent coming out. Insert it in when y is equal to 4, x is equal to 6. We pop that into our formula. So we get 4 3/4 times 6 plus c. And we have to go through the mathematics of this. So 4 equals, well, 3/4 times 6. That's going to give us 18 over 4. If I write this over here, so 18 over 4. I know many people like decimals, so that's going to be 4.5. Plus c, therefore c is going to be equal to minus 0.5 or minus a half. I'm going to keep it as a fraction, we're almost there. So y equals, this will be acceptable answer by the way, but I'm going to do a little bit of transformation. 3/4 x minus a half, and to get it in the form that they like in the exam, I'm going to times everything by 4. Okay, for as long as I times everything by 4, that's fine. And then we get 4y, almost there, 3x minus 2. Remember, a half times 4 gives you a 2. And I think that's the form they want it in. It is the form they want it in, but this would also be acceptable as well. It's the same thing. You can see it's 5 marks, there's a lot of work there. Let's see the method marks. 6/4 seen, yes, we wrote 6/4, that's good. Minus 8 over 6 seen, we wrote that as well here. Good, good. Did we see 6 over 8 or 3/4? Yes, we did. And then did the correct method to find c? Well, yes, we did. We worked it out using this formula here. Excellent, that's 5 marks in the bag. And we've got one more question, which people find very tricky. And once you know the method, do this applications IB as well, then it's very straightforward. So, let's see if we can get this done within 4 minutes. Y is proportional to the square of x. So our proportionality statement is y, this weird alpha symbol, is equal to x squared. And we convert that into an equation, y equals some constant k x squared. This is the step that many students do not write down clearly. Now we're going to use what's called our initial conditions, our initial values, to work out what k is. So when x is 4, y is equal to 8. So we pop that in. We've got 8 equals k times 4 squared. So it means 8 is equal to 16k. Therefore, k must be equal to 8 over 16 or a half. And now we replace that in our general formula, and so we get an equation connecting y and x to give us y equals a half x squared. And interestingly, it says values, so we're going to get more than one answer for this, so keep that in mind. When y is 32, we just pop 32 into that formula, so we get 32 equals a half x squared. So we times both sides by 2 to remove the fraction, so we get 64 is equal to x squared. So what I've done there is times by 2, my laptop's not leaving me alone, times by 2 on both sides, and now to work out what x is, we do the square root of both sides, so we're going to square root both sides, and then this is where we have to be careful when we square root, because you always get two answers when you square root, so x is equal to plus and minus 8. Clue in the question, they do say the word values, so we've got 8 and minus 8 to make this nice and clear. Good. Check the answers. They put 0.5, the same as a half, that's fine, and then 8 and minus 8 for our answers there. Okay, hope you enjoyed that video. That actually took shorter than I expected, but those questions are definitely at the more difficult end of the paper 2. All right, bye-bye for now.